Welcome everyone to this webinar. My name is Magdalena. For those who don't know me, I'm a Knowledge Exchange Coordinator for CIAT Scotland East. We are joined today by Dr Nicholas Harrington, who is a Research Associate with the UK Collaborative Centre for Housing Evidence. And Nicholas has very recently released a couple of really interesting papers to do with barriers to adoption of heat pumps and the running cost of domestic heat pumps in the UK. So without further ado, I'll hand over to Nicholas to tell us a little bit about himself and then about his research as well.
Thanks very much for that introduction, Magdalena, and thanks everybody for the attendance. I'm very much looking forward to sharing a little bit of the knowledge that I've produced over the last sort of 12 months with respect to heat pump running costs and the barriers to their adoption. So over the last 12 months, I've been involved in a large project for the Engineering and Physical Sciences Research Council, which essentially was the social science component was to find out what has been the cause or sort of slowed down the adoption of heat pumps well below the government's, anticipated or expected target of 600,000 deployments per year. And I used a systems thinking framework, so looked at all of the different mechanisms and different interrelations and linkages that exist in what we might call the sort of heat decarbonisation social system. That formed a sort of the analytic framework from which I approached the question. So what I want to do in the presentation is I'll speak a little bit about the findings with respect to the barriers and then also some of the material costs associated with the installation, setup of heat pumps and their running costs. In particular, it'll be running cost comparison to gas boilers. So in my most recent piece of research, I tried to find all of the demonstrator projects, the trials that have been undertaken in the UK in recent times or in the last decade and a half, where there was evidence and monitored data in the same domicile for heat pumps and gas boilers. So the research referring to the running cost of heat pumps doesn't include every single trial that's ever been conducted or case study or monitored data, but specifically those where in the same study they provided comparative information for the running cost of an efficient gas boiler and the heat pump, because that's, I think, if we're trying to displace an existing carbon emitting heating technology, then we want to know, and that's the dominant one, then we want to know these relevant pieces of information. And I wasn't in a position to estimate the running costs for a study that I wasn't privy to the actual data. So I needed to keep that to studies that included both of those pieces of information. So I'll start the slides and then at the end, of course, we can have some questions. So one way to begin, rather than asking simply what are the barriers to adoption, is we can actually do this in the reverse and say, well, what has enabled adoption? And a really neat data set for enabling of heat pump adoption is to actually look at the applications and vouchers that have been released through the boiler upgrade scheme. DESNZ keeps all of this data. It's really rich data set. There's lots of really interesting information. So it might surprise some of us on the call here to know that only a little over 17,000 vouchers have been received, or applications for vouchers. And so that's not an enormous number. There's around 200,000 registered heat pumps across the United Kingdom at the moment. So well below the targets that we have. Okay, that's clear. Now, what we know about the bus grants that have been issued is, first of all, we have average costs for Airsource heat pump installation, which you can see there, and average costs for ground source heat pump installations. Now, these costs include the unit, system design, emitters, pipe work, so everything that went into the installation, but it importantly doesn't include any additional fabric upgrades that may or may not have been instigated as part of that installation. So what else do we know about it? Well, 53% of those who applied for the bus grant replaced something other than gas. And this is important because they're replacing things then that are much more expensive than gas as an existing heating system. And one of the issues that comes across in the literature and all the research is that it's been difficult to displace efficient gas boilers because they're so cheap as a unit price. They're at least like a third to a half cheaper than a heat pump. And the total install costs are significantly less. And importantly, because of the electricity to gas price ratio, the running costs are a lot less. But what we see here is that the majority of people who took up the bus grant weren't replacing gas. They were replacing things which may have already been expensive forms of heating. The other thing to note is that the plurality, so the largest proportion of individuals who took up the grant were from the south of England. So does that say something about the view of the applicants and the climatic conditions? Perhaps it does, and this appears in the research. There still remains I would say an incorrect view, but a belief amongst the general population that heat pumps just generally work better or in warmer climates, or wouldn't work as well outside of more temperate climates. So that seems to be in evidence. So in terms of the research then, going through from my publication about the barriers to adoption, this is sort of in, I would say, a descending order of importance. So the number one biggest factor that has held back the adoption of heat pumps is the price of electricity, and particularly the price of electricity relative to gas. And why that's important is because a consideration of running costs feeds then into thinking about fabric, because the worse the fabric is in a home, for example, the higher the U value, the higher and the more quickly that the heat is transferred out of the property, or the higher the air tightness measure is, then of course the harder the heat pump would have to work, and therefore potentially the more expensive it would be to run. And so these are all considerations that are factoring into people's thinking about heat pumps. And so then one of the big things that emerges in the research and in the evidence is thinking about the condition of the existing housing stock. That is to say, because our homes are leakier, older, lose heat 3 times faster than our European neighbours, therefore people will think themselves or will be advised that they require fabric upgrades to the home in advance of installing the heat pump. And so now we end up at that material foundation, which is that it's really expensive to install a heat pump. And the current funding arrangements are not sufficient to meet that demand. So as we saw on the previous slide, costs around £13,000, £13,500 on average to install an Airsource heat pump, more obviously £26,000 for a ground source heat pump. If the government is providing £7,500 of grant monies, then the balance has to be met by the occupant. So you're thinking, or the people who have taken up the heat pump vouchers so far are individuals with that kind of surplus capital. So the capital expenditure is certainly a significant issue. And again, that doesn't include the question of fabric upgrades. Now, fabric upgrades become a concern, obviously, for a lot of social housing providers with whom I've had a lot of interactions and spoken to a great deal. There is a preponderance of a fabric first approach across the social housing sector. That is to say, they want to get the energy efficiency or the thermal efficiency of their homes up to spec before they start thinking about just putting in clean heat technology. And as we'll go through a little bit later on in the presentation, I think there is an argument that that is an appropriate view, but there are limits to that view. And I think we sort of need to perhaps move into a situation where, rather than saying fabric first, it's almost like saying fabric together. And then there are obviously many instances where you don't require to do additional fabric work, and the performance of a heat pump can be achieved with other measures. So what is a good heat pump? What does it mean to say a heat pump performs well, or is performing as we would want? Well, there are 3 components that are required, and you can't do without any one of these 3. You need thermal comfort, needs to reduce the CO2, but it also needs to be competitive in running cost. If we don't address the competitive running cost aspect of it, there will continue to be resistance from the general public, and in the absence of any strong mandates, the uptake will remain slow, as we have seen it. So the background, of course, is that there's no real mandate. So we are, or have been for the last 10 years, encouraging voluntary adoption of this process. And because there have been questions about the running cost and questions about what, if any, fabric improvements will be made, it has slowed down adoption. So what are the aspects of good performance? What elements of the system interact? Well, you have obviously the emitters. So in other words, that means how big is the radiator along the wall? Do we have underfloor heating? Then you have setup. So things like, what is the flow temperature? At what timing is the flow temperature coming on or coming off? And then you have installation. Is it the right size of unit for the property and the heat demand? And then, of course, you have the U value of the home. How quickly is that home losing heat? Now, you can't do without or focus on any one of these issues. They're all important. And so to get the best performance, a COP or seasonal performance factor of, let's say, 3.5 up to 4, which is what you would love to get, you need to address all of these dimensions. The most recent piece of research I did, as I said, was looking at the comparison between the running costs of air source heat pumps and efficient gas boilers. The graph that we see here on the slide indicates how much more expensive, or in the one case of the very last study, how much less expensive is it to run an air source heat pump compared to an efficient gas boiler in that home in which the study was undertaken. What you can see if you sort of step back is that the efficiency of heat pumps, or their performance relative to efficient gas boilers, has gotten a lot better over time. And that's an important factor because the improvement of the heat pump economic competitiveness has been improving as the price of electricity relative to gas has been getting higher. So in other words, the conditions for the performance of heat pump or economic performance has been eroded, but the performance has improved. So there have been absolutely, especially in the last 5 years, really strong strides about how can you compensate with better sized emitters, better setup, better system design. So as a general, the summary findings from the research were that in the evidence, in the studies that were observed for properties that had high levels of insulation, so for example, a home that was built to the New Home Standard 2025, they would achieve, on average, they would be 9% more expensive to run than an efficient gas boiler, which is actually pretty good. 9% is not that much, as an additional expense. For homes that were not extremely well, so the study said that they were essentially of an ordinary level of insulation or fabric efficiency. A lot of them referred to a C, EPC C rating. Those homes or running the heat pump in those homes was around, on average, of that collection of a body of studies, was around 36% more expensive. So for an average 2-bedroom, 2-occupant home, that was coming out to be about £550 extra on energy expenses per year. So that's now not negligible, and that requires some thought about how, especially for people who might be in fuel poverty, the 3% of UK stock that is below EPCC, we're starting to get into a territory where we're adding extra heating expenses and energy expenses. That said, with the right kind of system design, with the right sort of emitters and the right sized emitters, so the bigger the emitters you can install, the higher the wattage of output of heat that you can get from the same flow temperature. Just takes a little longer to get the environment up to temperature, but that's fine. Things start to become a little bit more favorable even in an EPC-C situation. So here we have a case study home. It's only a 5 kilowatt ASHP. That's not a big unit at all. The home is EPC-C rated. It does have good insulation and double glazing, but in the depth of winter, it was achieving a coefficient of performance of 3.23, and the air source heat pump was only 5% more expensive than the gas boiler. So we're now seeing the kind of performances that we were seeing in evidence at the very high level of insulation being achieved at a more moderate level of thermal efficiency or energy efficiency in a home based on better system design. Of course, we have the question of tariffs, energy tariffs coming in. So there's an OVO tariff, which is in cooperation with Valent at the moment. It's going to bring the cost of electricity to 15p per kilowatt hour, which is incredibly low. And at that level, the air source heat pump beats the gas boiler all over the place. But it's important to understand how long, or it would be important for any consumer to understand, how long would tariffs like that be expected to last? Are they an ongoing process, or is it an inducement to get an air source heat pump? The OVO program is a beta program to see how this actually functions in the marketplace. It's only available to the first 100 applicants, and we don't know what they intend to do afterwards. So I just put that out there because I often get questions about the tariffs. And it's true, there might be a private sector solution to this electricity price problem, but usually with tariffs, you want to know, well, how long am I going to be on that special tariff for? What I put up on the screen now is a very primitive estimate for the kind of seasonal coefficient of performance or seasonal performance factor that one might expect from various EPC ratings, or from an air source heat pump at various EPC ratings. Now, it's very difficult to make this a robust estimation because an EPC rating is a poor proxy for thermal efficiency or U value, particularly at the lower end, because we don't know whether that home has received a low rating because they have a very inefficient heating system. So they might be relatively well insulated, but on an inefficient heating system, and therefore their rating goes down. But if you put an air source heat pump in, it would actually perform relatively well. So these need to be taken absolutely with a grain of salt. But that said, it still forms the basis of some form of analysis or some sort of policy consideration, which is at the upper end, EPC A and B, heat pumps. Really, you should be able to just put them into homes without putting an undue burden on people, provided that the emitters and the system setup is done correctly. At EPCC, it's unclear. Every home will need an individual assessment. Of course, do we need to do a little bit of top-up insulation or double glazing plus all the system requirements? At EPC D, E, F, and G, I have not seen any evidence that homes could be expected to run in a cost-effective way unless they have, pretty meaningful interventions in conjunction with the air source installation. So price-wise, what are we talking about? For EPC A and B, you've got that 13,500 approximately, which we see on average from the bus grant scheme. At EPC C, it's going to be something between the cost of the unit installation and system design plus, let's say, 800 to 2,500, depending on whether it's just bigger radiators or whether it's underfloor heating to get that coefficient of performance, or a combination of both. At the lower end now, at level D, so the average to get a home that's D2C costs about £6,500. That's the average cost. So now you have 14,500 plus 16, so let's call it 20. And then at the very bottom end, the E, F, and G, you're now talking about deep retrofit. And Cash undertook a demonstrator project in Nidri Road, Glasgow, and the deep retrofit cost, including the air source heat pump units, was 30 to 40,000. So at the minimum cost for the highest performing properties, you're looking at about 13.5. In the middle, like 14.5 to 15.5. A next step down is something around 20, and then at the real bottom end, it's 30 to 40,000 per home. Now, of course, some homes, it might actually just be cheaper to subsidize the cost of heating that home, and that's something which a lot of people are thinking about. Is, well, is it actually worth spending 30 to 40,000 to bring this home up to spec, or are we better just giving that occupant an extra £1,000 a year for 30 years? So this is another consideration that is in the discourse. Air source heat pumps compared to ground source heat pumps. In the main, ground source heat pumps are more efficient to run. They just have a more efficient way of generating their heat to energy ratios. So they're about 14% more efficient across the studies than air source heat pumps. They are, of course, though, more expensive to install. But where a logic of a ground source heat pump starts to become, I think, more reasonable is with respect to shared loop systems. So in new home developments, if the scheme could be designed with a ground source heat pump shared loop system, then there are distinct advantages moving forward. They are about 40% cost advantage in the running costs over time on a loop system than if the houses had individual air source heat pumps. And the life cycle of a ground source heat pump is generally longer. So the underground works, the underground works for the air source heat pump have a 100-year life cycle, and the units themselves are somewhere between 15 and 25 rather than 10 to 15 years. So they do last longer, and therefore there are maintenance and life cycle costs to consider there. So just to finish up the intro presentation, there are other factors, of course, that impact the adoption. So we have psychological factors. So, for example, as I've mentioned, it has for a long time been a genuine and well-founded worry for local housing authorities and housing associations. They do not want to and cannot take the risk of putting their tenants into fuel poverty or exacerbating the fuel poverty that they may already find themselves in. So fabric first has really been a view which is quite prevalent. And, we're sort of seeing that the lower end limit of what kind of home can take an air source heat pump without exacerbating fuel poverty, that limit has decreased because of advances in system design and knowledge about emitter performance and settings and so on. Nevertheless, it is a genuine concern, and that has been something which has delayed the voluntary adoption. So in other words, people with limited resources and have, with sort of conflicting priorities, maybe have chosen to go down the energy efficiency and fabric first path. There is the performance anxiety from consumers, and we've seen that, of course, with the distribution of the applications from the bus grant. There seems to be still a prevailing view that air source heat pumps work better where it's more temperate, or if my home is already nicely insulated. And then there have been a variety of other things. I mean, of course, the sectors in the housing system are not equivalent. And so in the private rented sector, there's, of course, a big issue. And this issue, the split incentive, is shared now by, or will be shared moving forward with the developer sector and the new build sector, because the person who is investing in the heating technology will not be the direct beneficiary of cost savings accrued over the life of that unit. So this has long been an issue with landlords, the question of, if they're not mandated to, why would they put a heat pump in if they have to spend for it and then the benefit, accrues to the tenant? Similarly, though, if we have a question for a developing scheme, why would they put in a ground source heat pump with a loop system? It will be more expensive, it will be more time consuming, and the benefits would accrue to the purchasers of the homes. Would the purchasers, is the market mature enough that the purchasers will pay a premium for it? Is the consumer base demanding it? These are very much unclear. And of course, up until recently, one of the biggest barriers, and this sort of frames the whole discussion, is that it's all just been kind of voluntary. Who wants to, we're encouraging you, who wants to take a heat pump? Take a heat pump, they're really good. But there haven't been, so there've been certain small little carrots, but certainly no stick. And we're now starting to see stick in terms of mandates on new builds, that's for sure. And we'll get into a discussion about that. But that's a recent phenomenon. And it's something like, so there's like 230,000 new homes built in the UK on average over the last sort of, period of time. And that means that there's been, almost like 1.5 million new gas boilers have gone into homes over the last 5 years, which is certainly a missed opportunity there. And interestingly, in a comparison with some of our European neighbours, Germany, for example, which has long been considered to be I guess the leader in this sort of sector, or at least a lot of people have said, look at Germany, why can't the UK do that, et cetera, et cetera. If you stripped out from Germany's numbers all of the new builds that put in air source heat pumps, we don't actually look that different. So the big piece of the puzzle that was causing the distinction between Germany's air source heat pump and decarbonisation agenda and ours was that we just left the new builds, which were the perfect candidates to put these clean heat technologies in, untouched for so long. And that certainly is a bit of a shame. So I think I'll leave the presentation there and we'll have a bit of a chat and see what comes up from the questions.
Thank you so much, Nicholas. That was really informative. We've had a little bit of a chat before this conversation, obviously, and touched on certain aspects that we feel are important for CIAT members. Now, anyone can ask the question. Please pop them into the chat if you don't want to speak. But if you would like to raise your hand and ask a question directly, please do so. I've got a couple of questions that will start us off maybe. One being the recent announcement by the Scottish Government that they will be dropping the 75% carbon reductions by 2030, and the response of Scottish house builders to maybe have a look again at the upcoming changes to the legislation and the Passive House Equivalent Standard. Do you think this will have any impact on uptake of heat pumps?
So I think what's important is that despite dropping the target, the Heat and Buildings Bill still mandates clean heating technologies for all new homes. That, I think, is, without being too reductive, that's the most important piece of that puzzle, because they have, for a lot of homes that are being built, they will put a heat pump in, or a ground source heat pump, or some common, loop system, as we've said. I mean, they essentially they have to do that. I note that although there was a concern about banning wood-fired heating, and this is obviously a concern for more rural areas, there still is a provision for emergency heating. So hopefully that's something that, occupants who do rely on, wood burning heat can rely on, that provision, that they can consider that to be an emergency heating system. But back to your original question, I don't see that dropping the target affects the principal area with which that heat and building bill was going to address, which is clean heat in new builds, the thing that we haven't done. That's been quite a disappointing aspect of our legislation. So there's a couple of things to say there. One is we're always looking for some sector that can start to establish the maturity of the heat pump or the clean heat technology sector, because we have a really immature sector. We haven't got mature supply lines. There's obviously a skills gap there, all that sort of thing. So somewhere, somehow, we needed to have some sort of an intervention to disrupt what we call that market failure, that feedback loop, that because no one's doing it, there's not the demand, because there's not the demand, there's not the increased supply, and it just goes round and round. So now that there's a mandate on new builds, you can foreseeably see a significant uptick in orders for heat pumps that will address some of the supply chain issues, the delivery issues, and then the performance of those heat pumps, that also will flow through to the rest of the the society, the decarbonisation society, because then there'll be more people who will experience the benefits, more people who will have the experience of transitioning from heat on demand to thermal comfort and getting more used to that process, plus all the learnings, plus it'll get cheaper, the install. So I think it's very important. It's good that that's happening. It's over time. And that, putting it in new, so as we can say, UK wide, you're looking at about 200,000 new heat pumps. So we just went from doing 60,000 a year, which was the best for last year, to theoretically 250,000 a year. So if I'm being super optimistic, we're halfway to our target of 600,000. So it's not bad. I think it's definitely a good thing. So the target's dropping, bad, but in terms of what I'm talking about here, the clean heat, that hasn't been affected, and that is still going to be a necessary part of the program.
Perfect, thank you. I've got a question in the chat, so I'm going to read that out next. A question from Rose Slater. Other than the typical extra installation required, are there any other technical issues that are a common issue? And Rose goes on to say, on a recent project, I have had issues with Scottish Water requiring separate trenches for fresh water and heated water from a district heating system.
So, so aside from the insulation, I guess you're asking, are there other technical aspects that can improve the performance of the heat pump? I mean, the predominant ones are the lower that you can get the flow temperature, the more efficient the heat pump will run, the higher the performance factor. But you can only get a very low flow temperature if the radiators or the underfloor heating, whatever the emitter is, if they are significantly sized, or sufficiently sized, I should say, that you then can warm and meet the heat demand of the property. So there's all these things interacting, but I would say that one lever is flow temperatures. The lower the flow temperature, the better. The bigger the emitters that you can put in, the better. Obviously, the lower the U value, so the more slowly that the home loses heat, the better. And the smaller the unit that you can put into the property, the better. So all of those affect the running costs of the unit or its economic competitiveness. So obviously, insulation relates to U value, but essentially, what you want to do is you need to have someone look at a property or a case study of properties that really understands what is the heat demand of this particular domicile and what is the most efficient configuration of setting, emitter sizes, and potential energy efficiency upgrades that would be required to maximize the performance. And this is one thing that in discussions with policymakers, it's not, I mean, I don't want to be mean, but it's not as well understood as we would like, that there's a difference between system design and installation. So just calling Mitsubishi and saying, I want a heat pump in, is not at all the same thing as getting someone who is really au fait with and aware of the system design elements to say, okay, well, whatever heat pump you get in, that's not the issue, but what we need here is you're going to need 7 kilowatts or 10 or whatever, and you're going to need this and this and that if your interest is to achieve what we said, that triangulation of good good heat pump performance. Now, some people don't care about how expensive it is to run a heat pump. Okay, but when I do my research, because I'm always policy focused, public facing, my research is assuming that we don't want to pay more for the running costs. That said, there will be some people who will be prepared to pay more. You know, and I think honestly, I mean, I'm not sure if I would really be that troubled paying a little bit more myself anyway. So I think I fall in that category. I'm okay with that. But there are lots of people, I think we can say, you know, like, for example, fuel poverty in Scotland is 25%. So there's 25% of people right there who can't pay a dime more, really. So anyway, this is the sort of the thinking about it. Now, with respect to the district network, there are many issues with the district heating that people are coming up against. You know, there's even grid demand. So I'm not surprised, because there are infrastructure weaknesses that exist throughout the UK and in Scotland. Grid demand, you know, water provision, and so on. You know, one of the issues for inner city decarbonisation is that at present we don't have another solution other than heat networks or district heating. So if you live in, you know, a high density multiple occupant type of property, like either it's some sort of, you know, on-site communal, you know, sort of heat network, or it's, you know, district heating. So we don't have at this point a suitable individual level solution for heat decarbonisation. And with district networks, they're incredibly capital intensive. They also have a very long lead time. And by the way, this is just a material criticism. This is not a performance criticism. They are more efficient. They are, so a heat network or a district heating would be, it has economies of scale that flow through. They are more efficient. They're cheaper to run, theoretically. But the problem is, if they have such a high intensity of investment cost and lead time, who does that investment? Is it private? Is it public? If it's private, then there are questions which appear in the research about, is it good to create potential monopolies of energy provision for an area or a district? What happens? I mean, again, it's not clear, but it's a question. Will running costs remain low if you give over, you know, the management and the authority to a private company to provide for 5,000, you know, residents? What happens if their business case changes? What happens if the, you know, scaling changes? And then we can look to other forms of privatization. We can look to water. We can look to the railways. You know, sometimes they're cheap, sometimes they're not cheap. Anyway, these are all questions that I think that plagues district heating, which is, you know, something to consider. If it was public investment, like we do have examples of this, where the local authority built the district network themselves, and they provide affordable heating and electricity to their occupants and receive a revenue back for it. That model, I think, is a measure of comfort, public policy comfort, social comfort, which may not exist if you go and build a network for 4,000 people, give it to a private company and say, please don't pay us any more in the future. It'd be really nice if this was kept affordable for us all.
I think I would like to add to what you were saying about thermal performance, air tightness as well, because air tightness is actually quite a big factor when we come to assess older properties, especially. And that takes us into a discussion over comfort. And another thing that we will talk about in the future webinars is focusing on heat demand rather than U-value calculation, because it can be quite a singular indicator of performance, and it's rarely measured in situ. So sometimes looking at the heat demand or heat loss of a building rather than U-value is more beneficial. But let's move on to another question, because I can see that there's a couple of more from the audience. James Locke says, I've been reviewing this energy agenda for the last few years since the regulations updated. In terms of carrot and stick, as you mentioned, what's your thought on how this mandate be advanced? Would you think in the future mortgages in relation to EPCs will be valued in conjunction with RICS? The value of the housing which performs poorer is not valued as high as it once was, which is also something that we kind of discussed before, Nicholas, in terms of the increase in the value of the property.
Yeah, sorry, just before I go into that, I want to acknowledge the point you made about air tightness. Yeah, so I guess I'm just sort of, I'm using and it's not correct. I'm using these measures, although they're completely distinct, interchangeably as saying something to tell us how much insulation we need or how big the emitters are. You're right, heat demand is a very good example, and air tightness. And one thing I will say is that from the studies, the air tightness measure of 5.0 from the new home standard 2025 was sufficient to get the performance out of the heat pump. So that's good to know. So if you're going better than that, 1.6, 0.8, whatever, passive house standard is, obviously we know that they work well. So moving on to property values, once mandates come in to improve homes to certain levels of energy efficiency, or they have mandates of, like in the sort of the more existing housing stock sector to put in clean heat, it seems inevitable from what I've looked at with housing prices that homes which aren't up to code would be discounted by prospective purchasers. So I think that's logical, and I would imagine. I mean, what I have seen is, so Rightmove did a really significant analysis of all of the homes that marketed that they were energy efficient or had high energy efficiency ratings, and what the difference made. And it did make a considerable difference. It was something, and I can't remember it exactly, but it was something like the most energy efficient homes were 15% more valuable than the equivalent homes which could not declare that they had a high level of energy efficiency. So I think it is rational to say that the market will price in whatever the cost to do it is, especially when mandates are in place. So if I'm going to buy a home and I know that I can't replace the gas boiler with another one, and I have to put in an Airsource heat pump, and the home is a D, and I know that, in 6 months' time everything's going to need to be a C. When I go to negotiate on that property, as I'm sure most people will do, you're going to say, well, okay, well, I'm going to take 25,000 off the price because I have to think about the £6,000 to do the thing plus the extra work, whatever. And I think that would happen. So homes that are non-compliant or at a lower level would get discounted. The question of whether the more compliant or higher energy efficiency are worth more, I feel like that would just be, you'd observe that relatively. But I think it's more the issue that the non-compliant properties get discounted in the marketplace because they have this upcoming, material cost associated.
Thank you. There's another one that's quite interesting, and I think that kind of feeds into the heat and buildings bill. In the direction that's going. What, in your opinion, are the options for conversions in historic buildings with listed conservation valuable interiors where retrofit can be difficult with no associated land, particularly in dense urban areas? That's from Martina.
Yeah, I think Martina has described the absolute limit of what a hard to treat property is. So you have restrictions on, the sort of the regulatory like the building standard restrictions. You have physical restriction that you can't put something somewhere, and it's also difficult to do the insulation internally anyway. When I've been speaking to policymakers and looking at research around this, I think it may have to be something along the lines of subsidies of heating costs. So that home may need to be addressed with some kind of district heating, or somewhere it's off-site, and then the pipework is coming from somewhere else, like even a neighboring block that they're sharing their heating system. But because you can't do the maximal or optimal energy efficiency fabric upgrades, then that home may be, or depending on the occupant, might be eligible for some kind of energy subsidy, because there will be homes that simply, because of their physical limitations, cannot be put to a standard where basically the running costs would be reasonable, because you could just put a massive heat pump in the place or have that off-site, but then it would be more expensive to run. And if the occupant's okay with that, fine. Because I think that's something else to notice, that you can just scale up all of these technical components to the point where you could heat a barn with a massive heat pump. That's no problem. It would just be expensive to run because it's going to consume a lot of electricity. So again, it's just a trade-off. The occupant in that impossible to treat home, are they prepared to pay an extra £1,000-1,500 a year for their heating? Can they? If they are not or can't, then how do we address that, vis-a-vis subsidies? Because you're going to have to do something to sort of well, I would have thought you'd want to do something to address that. And if we're going to remain in this voluntary process, you're going to definitely need to incentivize them, because that person or that, the group of people have no motivation to move. So I think there will be technical solutions to that problem within the remit of those strict limitations. But at some point, homes that fall into that category, the idea of subsidizing their ongoing energy costs ought to be in the air, because you may never be able to get, I mean, it's kind of a law of thermodynamics. You're not going to be able to get a home that you can't treat to be as, have the same running costs as a home, all else being equal, that you could treat.
And I think that feeds into the human behaviour factor as well, and understanding how people use their building and what their perception of comfort is, which is completely intangible, so it might be difficult, and that's why retrofit plans are a tool that can address this, because we actually interact with people, and not only do we ask them for how they want to use their home and how they already use their home, but also teach them how to use the new systems. I think that's important, isn't it, when we interact with the occupants?
Yeah. No, I was just going to say that a lot of the demonstrator projects do user surveys, to see how they found it, and user behavior and understanding of the system is an enormous piece. So we talked about technical ways of improving the efficiency or the performance of a heat pump. User behavior is an enormous component. So what was found, especially with some of these social housing demonstrators, is that the occupants were quite unfamiliar with the idea of just persistent thermal comfort. That was unusual. So they walked into the home from being outside and thought it was colder than it was, for example, and then wanted to increase and get heat much more quickly at a higher level, which then changed the settings of the system and all that sort of thing. And so, in other words, the education piece, making the familiarity, holding, especially this new cohort that's coming through, because essentially it's a pretty niche technology now. 200,000 out of 27 million homes in the UK. There's not a lot of people with heat pumps, let's be honest. So the vast majority of people are utterly unfamiliar with what it feels like to live in a home with a heat pump, how they're meant to interact with that system, and so on. And that's a hugely relevant piece of this journey going forward, is that people, understand. And so, whatever projects, whatever schemes, how it's going with new build, with housing associations, and I know they've made these commitments. This is a part of it, that they really do have that custodianship about their residents and the people who will take these technologies over.
We'll maybe do one last question that's in the chat, and that's again from James Locke. In terms of decarbonisation, what are the differences between our other European governments and other European countries and their investment? Are you aware of what is happening in the continent?
So I can speak to Sweden, Switzerland, and Germany, because I'm doing a cross-country comparison with those. So Germany has super high funding. So they'll give you 27,000 euros to go and put a clean heat technology into your home. So that's pretty impressive, and that has meant that a lot of people have taken advantage of that. And I hate to be the guy that's like, but wait a second, but I kind of have to do that, because one thing that's happened is it's made the installs of heat pumps about 27,000 euros. So because what they did is they've been extremely generous with the funding, but they haven't looked, I think, carefully enough at how they cap who gets what. So basically, no matter what the home is like, the installer's like, well, I think this probably is going to cost about 27,000 euro. And so the cost of install and system design has gone very, very high. So that's just something to be aware of. But they have very good funding, and that's excellent. The other countries that I'm looking at, they have very, very different structural environments. So in Sweden, electricity is cheap. It's cheaper than gas. So they don't need to do this funding piece as much as we do, because it's already better off for occupants to put a heat pump in a lot of cases. And their homes have much higher air tightness. Much lower air tightness. So they're much more airtight. And consequently, it's the barriers, the psychological, the perception barriers aren't there in Sweden, so the funding hasn't been as important. In Switzerland, the average GDP or GDP per capita is like 2 times higher. So we're talking about a different demography. We have so many more people. So when I talked about fuel poverty, they don't even know what that is in Switzerland. And in Sweden, they are becoming aware of the idea of fuel poverty, but it's a new thing. So it's a different kind of environment. So there are structural differences. But we are actually surprisingly very similar to Germany, albeit our properties are a little older and not as, not as thermally efficient. But they have the same objections that we do, the same barriers. The barriers are very similar. So the main areas that are different between Germany and the United Kingdom is that they have been giving a lot more money, and they have had that mandate, not mandate, but they've encouraged new homes a lot more. So for the last 3 years, half of all the new homes built in Germany have been putting in clean heat. So they've had a massive head start on us with that. But so I can say that for sure. So Germany's much more funding, but they have a different economic model. They have more revenue, or they're a proper social democracy, or a little bit closer to that anyway.
Perfect. Well, thank you so much.